solve for all parts of triangles, you only have two ways to start. Okay? So if you're going to solve for your triangles, let me go up to here and just pick one of these real quick. And let's look at number 1 for an example. So in number 1, if we're going to solve for everything in the triangle, there's, like I said, there's two things. You're either going to have two sides, or you're going to have one side and one angle. Okay, what's that? Yeah. Well, I'll go back to another one then. So when you're solving for full triangles, there will only be two scenarios. One scenario is where you have two sides. The other scenario is where you have one side and one angle. Now, if you have two sides, think about the triangle. How many angles do you have left to find, and how many sides do you have left to find? You have one side and how many angles? Two, because the third angle is always 90. So if you've got two sides, that means you need to find one side, and you need to find two angles. I'm going to use theta, is that okay? Because we've been using for the angles in here. Same thing with the other one. If you've got one side and one angle, how many sides do you have to find that? Well, you know one of them. How many sides are trying? 3, so you have to find how many? 2. So here you have to find two sides and one angle. Okay. As we go through these things, the process by which we find all these parts, it doesn't change. It just means you're doing more math with each problem. Okay. So yesterday you guys were working through and you were solving for the missing piece, I believe, right? And like you were just saying, Mr. Fontana helped you guys out with number 1. So let's look at then, excuse me, let's look at, I don't know, 3. Okay? And we'll follow through the scenario of how we find our bits and pieces. And we'll make a list of what we would do. So in this case here, is this given two sides, or is this given one side, one angle? All right. Okay. So if we're given two sides, first thing we're going to do, we're going to find the third side. Okay. So if you're given two sides, to find the third side, use Pythagorean theorem. Yep. What's that? Oh. So no matter what you're always going to do when you have two sides, first thing you want to do is find that third side. Now that third side, it could be a leg, it could be a hypotenuse, it just depends on the problem. But you're always going to use Pythagorean theorem to get it, because Pythagorean theorem is pretty easy to work with, right? So if I'm looking at this one, what's my third side I'm trying to find? Is it an AB or a C? C is the hypotenuse, isn't it? Right. So find that third side. I would do 2 squared plus 6 squared is our C squared. Okay. So then in this case, this is just straight calculator. So 2 squared is 4, 6 squared is 36. That gives me 40. And then I just take the square root. Remember, multi-view calculators leave it in a simplified radical form. Anything with your phone book. And you're going to get 2 root 10. Yeah, put it away. Okay? So the calculator is going to give you 2 root 10 for that third side. So as we go through this, you start labeling your triangle for the parts you have. 2 root 10. Okay. There's your third side. Now you have to find your angles. So your next bit then, excuse me, ouch, sorry. Now we're going to use trig twice to find each angle. Okay. So we use trig twice now. And you always start with, in this case, notice how they have a question mark for the missing angle? We start with that. And what we always did is we circled it. And we went through our process. And here's my rule. Always use the given information. Okay? Always use the given information. Because if I use that hypotenuse law, and that hypotenuse was wrong, well, my next answer would be right. Okay. So you always reuse your givens. Always reuse your givens. What trig function am I going to use with an opposite adjacent? So I start with my theta here. So the tangent of theta is going to be 2 over 6. Remember to undo it, which you guys did really well, just inverse it. Inverse tangent of 2 over 6. Oops, wrong calculator. What'd you get? Thank you. 18.43 for that theta. So I have 18.43 over here. Ah, careful. What if that 1843 was wrong?
Oh.
See what I'm saying? If that was wrong, will that third angle be right? No. So that's why you reuse your given and reset it. Okay? So instead of calling this next one theta, I'm gonna call it. You guys ever use the prime symbol? You guys know what I mean by that? Here, let me show you. I'm gonna recircle this angle and redo it. Now 6 is my opposite. 2 is now my adjacent. What trig function is that? Tangent. And that's okay. So now I have my other angle, I'm going to call it this. Tangent of theta prime. It's just denoting it as a separate thing. Okay. What's the difference? It's a different angle. What do you, oh, I just switched angles. So instead of starting here to my opposite adjacent, now I'm up here. Different perspective, different view. It's just different angles. It just means it's still instead of using a different symbol, it's still an angle. It's just a different angle. How's it? There's a little tick mark above it. I don't know if you can see. I don't know if you saw that. It's like a little. You know how you use a single tick for a foot mark, like 12 feet and 12 and a dash above it. That's what that is. It's a kind of what it means by part. And then I just redo it. Now it's just 6 over 2. So that angle, again, inverse it, press the buttons, remainder. So inverse tangent 6 over 2. And you guys said 71.56? 57, excuse me.
You round up.
Now, if you take these two angles then, what should those two angles have to equal? 90. If you did it correctly, those two angles should have to equal 90.
Okay, let me check.
And that's the idea. The idea here is that you always do multiple trig functions just to make sure you're correct, because we know that it's so easy on the quiz, or I should say this, once I get everybody's in and done, it's so many people ask, and obviously I was sick yesterday, so I couldn't get caught back up. You guys are the worst. One of the things that happens is, and it happened a lot, you guys wrote everything out absolutely perfectly, but I could tell that you pressed the wrong button here or there. No, I'm just going over through right now, okay? So you guys did really well at writing it out. So continually do all of that, okay? So does that make sense by how I set that up? All I'm doing is Pythagorean theorem for missing third side, two different trig functions. Is it okay that it's tangent for both of them? Absolutely. Okay. It can change, and it'll always be tangent if you had to find the hypotenuse, because that means you're given your legs, and which trig function doesn't use a hypotenuse. Okay, and that's how you switch them through. Okay. That wasn't terrible, was it? And that's the thing, it just adds up a couple extra steps to the assessment. That's why I thought by starting with what you did yesterday, just by one angle, one side, it's really easy to add just a little bit to it. Okay. So let's pick one that wasn't. Excuse me. So let's pick one that. Let's look at 4 then. No offense to you. Let's look at 5. So number 5, again, same basic setup. We're doing another one that gives 2 sides to start with. What do you do always to find the third side? Pythagorean theorem. Okay. So to find that third side. Now, is that third side a leg or a hypotenuse I'm finding? It's a leg. Very good. Okay. So I know that to find my third side, I'm going to do something squared plus 26 squared is 27 squared. Be okay with that? All right. So that means in my calculator, all I have to do is type 27 squared, subtract 26 squared. And I get 53. And then what do I do to the 53 to get it by itself? Very good. All right. So I square root 53, and it's going to give me square root of 53. And is that okay to leave it like that?
Yes.
Absolutely. Okay. Some of you guys freaked out on that quiz where you had to take that square root of 13 or the sine of 13 or 15 or whatever it was. You got that negative 16 plus or minus 3 root 2. It's okay. Because 15 is half of 30, and that's where you get those weird angles. No big deal. So my answer here for that third side is square root of 53. And I leave it. Then I go to my angles. Right. When you guys went to your angles, you started with that theta. You drew to your opposite, you labeled your sides, and you probably used cosine, didn't you? I hope you used cosine. Did you use cosine to find that theta? Okay. So that first theta was cosine theta, 26 over 27, so inverse cosine. What was it, bud? 15.64 was our first theta. Does everybody agree with me on that one? Because that's an adjacent hypotenuse. So, I did, but I'm not using what I never use what I saw. I'm using my beginning. Okay, always use your givens. Okay? Because what happens that root 53 was wrong? Will my next part be right? All right, and that's the whole idea. If you think about it, there's 3 parts to each one of these, and each part is theoretically independent of each other if you reuse your given. All right. What's that? Okay. So then I reset. And then I circle the other theta. Now when I draw, 26 is no longer my adjacent, 26 is now my opposite. Okay? So here, I'm not worried about this one anymore, because this was a given, not a given. What trig function will I use for this one? Sine. So the other theta, theta prime we'll call it, if it's, oops, two equal signs. What'd you get? Press the buttons and lo and behold, one of those 2 angles add up to equal. Right. Yes, sir.
Why is
I'm at a different angle. When you're in the problems, you have to, find one angle, and you gotta find the other. You change your perspective, you change your spot. So this is now you redo it, this is now your opposite. Hypotenuse never changes. Opposite and adjacent flip-flop when you change angles. That's the idea. Okay. This one.
Next time, people will just remember to not put the knife down, because you like in the way, and when I try to write down front, I cut it off.
No.
What am I concerned?
Now, you were asking earlier, you always use the tangent. You only use the tangent when you don't know the hypotenuse. If you know the hypotenuse, you're always going to use cosine and sine. It just depends on which one you use first. So if you use cosine first, guess what you're going to have to use second? If you use sine first, guess what you're going to use second? That's how it works itself out. Okay. So we don't. Let's go to number 10. So let's start with number 10. Sorry, excuse me. Thanks. What's that? I'm sorry, I was homesick.
No, it's fine, just know.
I wasn't going to come in.
It's not for it.
It wasn't that hard to draw. Anyway, so in this case here, we have two sides, no angles, which means we got to find the third side and then find two angles. Okay. To find the third side, you always use Pythagorean theorem. Is the third side in this case a leg or a hypotenuse? A leg, good. So we start out with that. Good. So you have x squared plus 25 squared is 35 squared. So you have x squared will equal 35 squared minus 25 squared. You said 600? Okay. And then we take the square root of that. Yep. So our third side, we hope, is 10 root 6. So we just write it down. Okay. Now, I'm just going to put it here for right now. What'll happen on formal stuff, I'll write in, you know how we were doing with, when we did special right triangles? Remember how I said, find AB, find BC, AC, things like that, I would label out the actual side lengths or find the angles. I'll have them written out so you know which parts you're solving for, so we don't have to worry about labeling things in. So now, we go through our angles. We start with the first angle, circle it. 25 is my opposite, hypotenuse. I'm not going to label the part that I wrote in just because in case it's wrong. It's not, but just in case. Okay. You never want to reuse what you did, if at all possible. So what trig function am I going to use to start with? Sine. Very good. Sorry. So the sine of something is 25 over 35. Oh. Notice how we're still writing everything out like we would. 44, 32? 42.
44.42.
I'm only a little congested.
It's okay.
Just a smidge, not a lot. Just a little.
I like
Excuse me.
I got 45.5.
All right, so let's do this again. Inverse.
I'm
Okay.
wrong. All right, wait a minute.
What was it? Inverse sine
25.
25, 35. 45, 59, 58. Did you do cosine by mistake?
I did sine.
I think it's you're up. You're up. Yeah. Whatever. So 45, 58. Okay. Now, that's from the one angle. What do I do to find the other one then? Remember, reset. We go back, oops, if I go back and circle my other angle, I don't know this, but this is now my adjacent. What trig function do I use for the second time? Cosine. So the cosine excuse me. I was wondering, because I wonder if you flipped and hit cosine numbers. That's what I was asking. That's why I was asking the arrow up to see what you would press in the type, and it must have cleared itself out. So this one was your 44, 42. Okay. All right, you're halfway there. Now remember, those two angles when you're done, they should always add up to equal 90 if you did it correctly. Or obviously within your realm of a couple hundredths. Yes, ma'am. Correct. Yeah. You always want to try and, when you're doing angles, just reuse the two sides of the equation. So you're going to use two different trig functions. If you have the hypotenuse, you use trig functions. If you don't have the hypotenuse, you're still going to use tangent twice, but your fractions twice. And you'll see that as the trig as you go. Yes, ma'am. I'm sorry, what's that? What happens is we're just solving for every piece. So could you use trig to find that side? Yes. But the problem is that what happens if one of your angles was wrong that you solve for? Will that side be correct? No. So an independent way to do each problem separately is to do it in three separate problems. First problem you would use Pythagorean theorem, and then don't worry about that answer. One trig function for one angle, one trig function for another angle. So you have the probability of getting all three of them correctly, or getting two of them correct if you get one of them incorrect. You know what I mean? So by resetting it each time, you still can get it right. That's why we do it. That's why I do it this way. It's a little different. All right. Let's try one when you had to do a side of the angle. Okay. Those are actually a little bit easier. Okay. If we go back to the sheet, I think those were the problems towards the end. So if I look at number, let's look at 14 real quick. So when we have one side, one angle, first thing you're always going to do is find the missing angle. So find the third angle by 90 minus given. Okay. Do that first, and then don't worry about it again. And then you'd use trig twice to find sides. Okay. So first thing you would do, I know this one's 90. I know there's 180 degrees to go all the way around. I back out 90. That means these two are always going to be complementary. I take 90 and I subtract 48. What are you left with? 42. So I know that one angle is 42. From there, I don't worry about it anymore. Got it. Yep. And then I go through and I do my trig stuff. I circle my 48. I have my opposite, hypotenuse, and adjacent. So at this time, it's a little bit easier because what are the two sides I'm trying to find? The hypotenuse and the adjacent. So what part am I given? I'm given the opposite. So I'm looking here, I'm going to use the two trig functions that have the opposites, sine and tangent, to get the hypotenuse, to get the adjacent. 90 minus 48. always take 90 minus whatever your given theta is, and it'll work. Okay? So now I know that if I do the sine of 48, it'll equal 14 over my hypotenuse. And if I do the tangent of 48, it'll equal 14 over my adjacent. And this is where I like to leave in the letters, so I know what part goes where. This is still that style that a lot of you guys are mixing up. Notice in both of these, your unknowns are in the denominator. That means you have to do, remember we called it the good old-fashioned exchange-o, change-o? Make it work, okay? So I know that when I press some buttons here, my hypotenuse is going to be 14 over the sine of 48. My adjacent will be 14 over the tangent of 48. From there, I've got all my trig stuff written out. Now I press my buttons. Okay. So let's see here. 14. I'm sorry, excuse me. Ouch. Hurts. 14 over sine 48. I have 18.84 for the hypotenuse. And then I do the same thing with tangent, 14, tangent 48. And I have 12.61. Now, the only downfall with a lot of this right triangle stuff, it's tough to know if you did it right. One of the things that I can show you though, if I put 12.61 here, and I had what, 18? If your largest angle, obviously in the right triangle, your largest angle is always going to be the right angle, correct? If that side length is the largest, you're probably in the right track. Is 1884 bigger than the other two sides? Now, 48 is bigger than 42, correct? Left side check. Is the side opposite bigger than that side? Remember how we talked about largest angle always says the largest side, smallest angle, smallest side? If those parameters, remember we opened and closed our hands, if those parameters hold true, you're probably on the right track. Okay? You could check this with the Pythagorean theorem. It's probably going to be pretty darn close, but it's not the end of the world. All right? So again, when you're finding two, third angle super fast, and then it's just two trig functions. I think this one's quicker. My own opinion. Not terrible, is it?
Well, it's not a word.
But if you think about it, it's the same thing we're doing. It hasn't really changed that much. Let's try another one like that real quick.
Just an extra.
Let's see. Let's do. Now we'll do this one. It's 17. Let's try 17. Oh, excuse me. A hot coffee, that helps.
That don't help. You put me like here.
No. So that's a 15. I don't know if any of you guys thought that was a 5 by mistake. So first thing we do is find that third angle. So we take 90 minus 15. What do you get? Okay, good. 75. So we know right away. Take 90 minus the 15, we get 75. There's our first angle. And then I go back and label. Opposite, hypotenuse, adjacent. We need to find an opposite, and we need to find a hypotenuse. So I know I need to find a hypotenuse, I need to find an opposite, but I know my adjacent. So the one that works with adjacents, since I'm using the adjacent side twice, it's going to be cosine tangent. Cosine 15 is our adjacent, which is 12 over hypotenuse. tangent of 15 is our opposite over the adjacent. Start to see why we label everything? Makes everything easier. The more information you write out, the more information you have in front of you by using up all this stuff, it just makes everything easier. Exactly. It's very systematic. If you've got it all right in front of you, you know exactly where to go. Yep. So now this first one, change-o. So your hypotenuse. Be 12 over the cosine of 15. And then this will be 12 tangent of 15 is your opposite. Cosine 15. Oh, that's weird. Yeah. Oh, it's okay. 15 is half of 30, isn't it? Remember I told you guys a while back, we get these things that are called half angles. So half angle, double angle, there's all these weird theorems that show up in pre-calc. You guys get there. And 30, I mean half of 30 is 15. That's why you see this weirdnesses up there. That's okay. You just hit the double arrow, no big deal. And you get 12.42. There's your hypotenuse. Do the same thing with tangent. Did you get a funky answer there too? It's fine. No big deal. All right. It's all right. Bless you. Again, hit the double arrow. We get 3.1 or 3.22. You will always get weird answers with 15s and 75s. And if the angle's at 15, or the angle's at 75, you're going to get weird answers. And that's okay. There's nothing wrong with it. All right? There's nothing wrong with that. Then, I want you guys to try one on your own here. So find the rest of the parts on number. Find the rest of the parts on number 24, please. Okay. Find all those parts on that one, all right? I'm trying.
Yeah, like how many more weeks left? Like that.
Wait. So I'm guessing first thing you guys did, which is probably easy, 90 minus the 29, and I hopefully got 61. Good. Oops. So there, we know that one's the easy part. All right. Now from here, always go back to your given, 29, label opposite, hypotenuse, adjacent. What two sides do you have to find? Opposite and adjacent. So that means what trig function are you going to use? Sine and cosine. Good. So the first one we'll do, sine 29 is our opposite over 13. And then cosine of 29 will be our adjacent over 13. Again, notice 13 is our hypotenuse. We're just reusing it in both trig functions. Then the algebra, the solving of it is easy. Yes, ma'am?
So, this, you're basically just like whichever side that you're doing, just use whichever function
Yes.
that you put that side.
Yep. And that's how this works. And same thing with when you're given the angle, when you had the other stuff, when you're given the two sides, you just use those two sides with the two different angle spots. Because obviously they rotate for what, if you have a hypotenuse, it never changes, but the adjacent and the hypotenuse, that's why those things you flip-flop and redraw. Okay. So the other one, the 13 cosine. So did you guys get, let's see, 13 sine 29, 6.3. It's okay, sorry. It's 6.3 on that first one. And then you said 11 point something? 11.3 side. So one of the things is that we know that the opposite side was 6.3. So I'm looking at the opposite side, that's 6.3. And the other side was what, 11? Now, one of the things you could do, I could use the Pythagorean theorem, do 6.3 squared plus 11.37 squared, take the square root, it should be pretty close to 13. You're going to be within rounding error on that. That's one way. Or another way, just to kind of quick check. 61 is bigger than 29, right? So the side across from it has to be bigger than the other. See how that works? And then 13 is your hypotenuse, which has to be the biggest. That's what we do. So,
Wait, how do you put in this part again?
what?
What did you just say?
Oh, all I'm saying, remember the biggest angle, remember we did this? Biggest angle, biggest side, that's all we're doing.
Oh.
It's just a quick reference to see if it in fact is kind of more than that one. Okay. All right. So let's do this. I think I have a sheet. Yes. So what I was planning on doing with you guys with this stuff this week is that I know that we have that short day on Thursday. Yeah, short day on Thursday. And when we go through these things, I was thinking about doing a short quiz again with solving for everything in a triangle before we got to the angle of elevation and stuff. So that's kind of what we'll do. We'll still shoot for that. On this one here, I apologize, I didn't space it out as much as I had anticipated. I don't want to do that in any of them, all right? So let's do, let's see. Let's do 2, 4, and 6. So solve for everything. All right. And then on the back, let's do, try to mix it up some space here. 10, 11, and 12. Now, one of the things I was going to say Caught one of them. 2, 4, and 6. You have enough room to do those, all those bits and pieces out there. I didn't space it well enough in the back part to do that. If you want to do those on a separate sheet, that's fine. That way there's only 6 of them. I didn't want to overburden. Obviously, you guys, it's the same thing we've been doing. You're just adding an extra step to everything that we've had. You guys can kick your butt on these things. Hopefully, if you look on Skyroad, you'll notice that your grades were really good on that quiz. Actually, the past couple quizzes, you guys did really well on this stuff, so just keep it up on that. I'm going to get the quizzes to the other people that were absent today, so hopefully I'll get all the other quizzes to you guys tomorrow. And then, like I said, on Thursday, we'll have a very short quiz, maybe 4 total triangles to solve for all the bits and pieces and go from there. Thank you, guys. I apologize for the...